Hello, everyone. I'm Stacy, Senior Community Manager from Postgres Professional, and today we'll learn how to do database audits for PostgreSQL. At this event, you will get practical advice on how to configure PostgreSQL, how to use various tools and methods for the timely detection of performance issues. We'll also take a deep dive in PG Profile historical workload reporting tool. Please note that this event is being recorded, and we will provide the link to both slides and video soon. You can type your questions in the YouTube chat, and we'll collect them from there. So, I'm done with my housekeeping notes, and my colleague Andrey Zubkov, our Senior DBA, PG Profile Developer, will and maintainer will take the stage.
Hello, my name is Andrey Zubkov. I'm Senior DBA at Postgres Professional and a maintainer of PG Profile tool. It's nice to meet you on our event. This talk is about historic workload capture and analysis tool named PG Profile. So what's the problem? The first question mentioned is mostly related to general query optimization. This is the case when your system is working as expected, but you are looking for the places worth to optimize. The second question is related to issue investigation. It's one of those Mondays when you were reported about system performance degradation, and all around blaming your database waiting for answers. Such a real case we will investigate today. Currently, there are two ways available. Collect logs with later analysis, as PG Badger is doing this, and collect increasing performance statistics. Actually, there is one more way, usually called sampling, when you are frequently checking what every backend is doing right now. But this way has a performance considerations and is useful in transit problem investigation rather than general analysis. Increasing statistics that we are using, of course, is not a silver bullet. PG stat statements right now can't show us the statement plans and their execution statistics. Also, statement parameter values is unavailable and failed statements isn't visible. However, using increasing statistics, we can capture the summary database workload with infrequent sampling on regular basis with reasonable overhead. Postgres Professional solution PG Pro Stats is able to capture execution statistics on the plan level. So, PG Profile is an extension written in pure PL/PGSQL. You'll need only some kind of scheduler for tracking your Postgres workload with regular samples. You can build reports or differential reports on any collected sample sequences. PG Profile sampling collects data from all useful increasing counters for all available objects, but not all counters are saved in samples. We'll storing statistics for top objects only, saving some space. This is Postgres Pro. There is Postgres Pro fork of Postgres database containing PG Pro Stats extension, providing statement plan statistics and weight sampling. This data is used by PG Pro Power fork of PG Profile. Now, let's see one simple example. We'll consider a real case of our customer. All names are obfuscated and no statements will be shown, but all statistic values are real, and this is all we need for the demonstration. It's a very simple example of an issue with increased blocks hit rate. It's an increasing statistics measuring total amount of blocks found in shared buffers by all sessions since statistics reset. This metric can be monitored easily. On this chart, we have to days long time interval where we can see the point when blocks processing has been raised by several orders of magnitude. It may be normal, but maybe we are just wasted CPU time in unnecessary page processing. If our monitoring system tracks aggregated statistics of pgstat statements view, this issue can be confirmed in similarly raised execution time metric. It means that summary total execution time of all statements in your database is increased too. Now we know for sure that something is changed in our database workload and further investigation is needed. Monitoring system can do nothing more, and we need to firing the next stage. In our case, it will be PG profile. Of course, PG profile might be installed beforehand and sample collection must be set up properly. First of all, we'll build a report on time of issue to see what was the cause of resource utilization. The report is a regular HTML file containing several sections. So what's in the box? This is a report table of contents. You can click any title and move to corresponding table in the report. Server statistics section shows overall cluster statistics for report interval. SQL query statistics section provides information about top statements by various criteria. Schema object statistics will show you top tables and indexes, and so on. I can't include whole report using a presentation software, so I'm going to show it online. One moment, please. Here we are. Report looks like this. Server statistics section in table of contents, SQL query statistics sections, schema object statistics, user function statistics. Each section is divided in subsections with tables sorted by various criteria. Let's go to server statistics. Database statistics provides information from pgstat database view for all databases. For report interval mentioned here in the header of report. Server statement statistics by database is aggregation from pgstat statements view. Cluster statistics mainly captured from pgstat bgwriter view. Table space statistics provides information about size and growth of table spaces in our database during the report interval. SQL query statistics section provides many tables sorted by different metrics about statements captured by pgstat statements extension. Every query ID is a link, so we can click on it and see the query in queries list highlighted. So, schema object statistics contains information about tables and indexes and load on them. User function statistics provide information about function execution, total time, and executions count. Separate table shows information about trigger functions executed in your database and time needed for this. Vacuum-related statistics section provides information about vacuum operations on your tables, also analyze operations. Indexes by estimated vacuum I/O load provides information about implicit index load caused by vacuum on underlying table. And the last section of report is settings, and they change during report interval. So As you can see, the report is quite informative and its examination is quite interesting. Thanks to the monitoring system, we know the exact time when the issue was happening. So we'll build a report on 11 a.m., 1 p.m. time interval. This interval is bounded with blue lines on the chart. This interval contains 4 samples since 130 till 134. Report building command is really easy. You also can build a report using a real timestamps as boundaries, but there is no place here for 2 timestamps, so I've used sample identifiers. As we know, our issue is related to statement execution time and block hit rate. Those corresponding sections will be the first to look at them. Let's see statements by execution time. Statements in every table of a report are sorted by corresponding statistic value. In this table, it's total execution time during report interval. The first 3 statements have consumed over 65% here of all execution time in the cluster. Query ID is a link, and you can click on it to see actual statement. This talk is not about query optimization, so we won't focus on exact statements. I just want to show how to find them. Now let's look at statements by blocks fetched. According to this table, leading 3 statements have consumed 91% of all page fetches in the cluster during a report interval. They are all in top 5 list of the most time-consuming statements. I've noted statement time rank with the red labels. You won't see them in real report. Those statements are the first to optimize. And what can we say about relations affected by our issue? Let's see tables by blocks fetched. Almost 55% of a cluster block fetch was done from one table named I6NM. Summarizing block fetches for 2 leading tables and their indexes, we will get impressive 93% of the cluster block fetches. And if you want to dive a bit deeper to see exact indexes affected, we should look at another report table, appropriate name, top indexes by blocks fetched. Index I6DTD-PK on the table I6DTD, likely primary key index, is the heaviest loaded index in our database. 28% of cluster blocks was fetched from this index. So, using a report, we can locate heavy queries and the hot objects for some time period in the past. But there's more. We can build a differential report. Differential report is used to compare workload of 2 time intervals. Same statistics are located nearby and highlighted, making it easy to compare. I'm going to show it right now. Differential report here. Differential report has the same sections and the same tables, but now for each object in table, we have 2 rows for first and second interval. Intervals are mentioned here. And here we have 2 rows for first and second interval. You can put your mouse on the number of interval and you get the time of this interval. So every metric for every object is shown for first and second interval, and you can easily compare it. All tables the same for regular and differential report, so I won't stop on them. I think you got the idea. Let's see what has been changed since previous day when the system was working as expected. We will examine differential report comparing interval 11 a.m., 1 p.m. of the previous day with normal workload with interval 11 a.m., 1 p.m. of the second day when the issue was in progress. The normal interval is bounded with blue lines on the chart, and the issue interval is bounded with red lines. In all sections of the differential report, cells containing information about the first interval will be colored red, while data belonging to the second interval will be colored blue. Significant workload raise is obvious even at the database level. Good interval is highlighted with green and bad stats is highlighted with red. Of course, in real report, they all are black. What's about time-consuming statements? We are observing significant statements workload change between first and second time interval. Almost all bad statements performed much better before issue. They took noticeably less time for more executions. The leading statement also was returning much less rows before issue. We can see this here. We can guess significant condition change of that query. Certainly, we want to compare tables workload from the point of blocks fetched. Let's look at the table named top tables by blocks fetched of a differential report. Here you can compare workload change on the leading tables. The same 4 orders of magnitude change in the heap blocks fetched from the leading table I6 and M. We can see this here. Using a report, you can obtain information of the most resource-consuming activities in your database. And using differential report, you can see the workload scaling between 2 intervals. PGProfile will help you to locate the problem, but it's not smart enough to provide a solution. However, when the tuning is done, you can use PGProfile to assess the results. PGProfile is an extremely easy tool for tracking and reporting about workload on the Postgres databases. The main design idea of PGProfile is that you won't need anything but Postgres database itself and some sort of scheduler to use it. And what about the cause of our investigated issue? We don't know exactly. Our customer was able to fix it after we provided our findings based on PGProfile reports. PostgreSQL databases provides some additional statistics that are used by PGPro Power edition of PGProfile extension. I'll try to show how it looks like. Here we are. PGPro databases contain some sections, additional sections, weight statistics by database, the aggregated statistics by weight event types for all databases, top weight events in all cluster, statement statistic tables contain plan ID field because in PostgreSQL databases, execution statistics of each plan is available. We can click on plan ID to see the exact plan. Also, we have SQL query weight statistics for each query. We can see overall waited time for each plan and details for weight event types. You can click on weight event type for this plan, and you'll see this plan in corresponding weight event type section of this table to see what certain events this statement was waiting for. That's all. Thank you for your attention. I'll do my best to answer the questions if we have one. So we have a question. What version of PostgreSQL supports pgprofile? pgprofile was initially developed for Postgres 9.6. Right now, it must work with all versions since 9.6 till 13. And of course, it will support further versions. Here we can see links for pgprofile on GitHub, Postgres Pro Standard Edition, and Postgres Pro Enterprise Edition available from Azure Clouds. As I know, Postgres Pro Standard Edition is available with no additional cost. And it's a great opportunity to try PG Pro Power to see weight stats and plan statistics. One moment, please. We have some technical issue. Oh, it seems, we have one more question. Question is not clear to me. Assume that weight events is more, how to tune, what to more. This question is not clear to me. Okay, in the end of our event, we'll have question and answer section. So I'm going to wait for Peter Petrov with his presentation. pgprofile is equivalent to aware in Oracle. Of course, it is. pgprofile was developed as a replacement of AWR of Oracle in Postgres databases. So, Peter Petrov.
Hello, welcome to this talk. I hope you can hear me well. First of all, let me introduce myself. My name is Peter Petrov, and I'm a database and I'm database administrator who has been working with Postgres Professional for almost 5 years and have been participating in various tasks such as data migration, query tuning, and system audit. And I would like to share some information with you. I hope that this information will be useful. And before we start, let's have a quick look into our agenda. The first thing I would like to discuss with you is what are data checksums, why we should aware about them, how to activate them, and how it can help us to prevent our system from data corruption. The second thing I would like to discuss with you is how to tune our Postgres parameters for better performance in terms of memory usage, logging, and planner. The third thing I would like to share with you is a list of useful extensions for better diagnostics and troubleshooting. Of course, my colleague Andrey Zubkov has recently mentioned PG profile, PG stat statements, and PG Pro PVR extension. However, there are much more. And I also would like to share it with you. And we also have a quick look into Mamunso. It's an active Zabbix agent, which was designed in Postgres Professional Company, and what additional metrics it can provide to us. Then we will have a quick look into kernel parameters tuning. To be more precise, it's about huge pages and transparent huge pages, how to activate and deactivate it. And the last thing I would like to discuss with you is how to prepare for the unexpected, how to be prepared for internal errors, and therefore why we need to install debug symbols and debug info packages. So let's get started. So what actually are data checksums and why we should be aware about it? You see, in Postgres, our data are divided into segments of files, and the maximum size of a segment or a file is 1 gigabyte. And as we know, our segments of files are divided on data pages. Each one can be 8 kilobytes, or you can configure it by yourself by using configure if you're building Postgres by yourselves. But in most cases, you probably use binary packages. And each data page has data checksums, and it contains a hash sum of its content. And why it's important? Suppose you have a query and it needs to read some data from the disk. These data pages is extracted from disk and placed in the shared buffers, data page caching for every Postgres backends. And then it calculates data page content and compares with checksums, which is stored in the data header. And in case if they're equal, it means that we don't have any mismatch, and therefore we can proceed our query. However, if there are a mismatch, then it means that we have a data corruption, which is a pretty nasty thing, since we cannot use our database, and we should switch on replica or perhaps to restore our database from a backup. And alas, when we install our Postgres, by using any DB, by default, these data checksums are disabled. You can check it by typing the following command in PSQL: show data underscore checksums. And if it is off, it means that your data checksums are disabled, and therefore you must activate them. First of all, you can do it by using any DB -k option. But you may ask me, but Peter, what if I have already had a running Postgres instance and I have a lot of data, for example, several hundreds of gigabytes or perhaps terabytes, and how can I activate them with zero downtime? Because PG checksums, we can use it, but first of all, it's only from Postgres 12. And the second thing we need to keep in mind is that it can only be applied on a cluster which was switched off earlier, but that's not a problem if you're using replicas. And this approach was proposed by Michael Pakwer, a core database contributor and developer. And the main idea is the following. You have your master and you have your replica. First of all, you switch your replica. Then you restore your data checksums by using PG checksums. After that, you check it by using PG checksums again with a different option. After that, you activate your replica again and wait while it applies all changes from the master. Then you switch your master off. You promote your new replica to a master, to be a new master, and then you redirect your business application to work with a new master. And please keep in mind that you must be able to store your write-ahead logs somewhere else. For example, you can use archive command, or perhaps you can use pg receive val, but you must make sure that when you restore your data checksums on a former master, you must make sure that it has sufficient information to replay all changes and to be a new replica for a new master. And if you want to, and then you can just change them. So the new master became a replica, and a former master becomes master again. And if you are on Postgres 11, it's not a big problem too, because you can use this PG checksums by following this link. And by the way, it works for Postgres version less or equal than 11. As far as I know, it can also work with Postgres 9.5. And by the way, the creator is the same who wrote this utility for Postgres 12. And if you follow this link, GitLab, you can see that colleagues from GitLab have tried this approach. And as far as I know, they have 4 or 5 maybe terabytes of data, and they haven't encountered any problems. So you can download this utility and try it by yourself. And you can also see how engineers from GitLab have done this task. However, I must warn you about one thing, that in a normal workload, we will not scan all data blocks. And therefore, we may not be able to detect data corruption. How it can be? Perhaps it's a software failure, perhaps it's a hardware failure, or perhaps it's some problem with virtualization, or maybe with the clouds. However, we must check all of it, and the only thing that can help us is a backup utility. And what should backup utility do? It should scan all data blocks, compare the checksums, and if it encounters any mismatch, it must report an error and exit, or it can display a warning and continue to do its job again, since we want to know what data blocks are corrupted. So, and speaking about backup utility, let me say some words about PG-Pro Backup utility. It's a tool that was designed in Postgres Professional company. It allows you to create backups and restore from that. It provides various options such as incremental backup. There are 3 different strategies to do that. Of course, you can do a full backup, and of course, it does validation. It compares data checksums and see if there is any mismatch. And of course, it verifies backup after it was created. And it allows you to use multiple threads to speed up your progress. If you have ever used PG-based backup, you can see that it can only work by using one thread and one process, and therefore the things can be a little slow. But PG-Pro Backup can help you with that. It also allows you to compress your data. You can also do remote backup and remote restore. And you can also make a backup from a standby and restore it as a separate replica. So there are various things you can do with PG-Pro Backup. And in the end of our talk, you will see the links which you can follow to read a full list of features about PG-Pro Backup. And by the way, we have binary packages for original Postgres, for so-called vanilla Postgres. So you can download, install it, and feel free to use it. And the next thing I would like to discuss with you is about memory consumption in Postgres. Of course, you have already known about these parameters. However, let me tell you something about interesting caveats. As you know, shared buffers is used to know how much memory will be allocated for Postgres database for its data caching. You know that the reasonable starting value is 25% of overall memory on the server. However, if you have a lot of memory on your server, perhaps you should activate huge pages. The way of activating them will be presented further. And now I would like to tell you something about workmem, which is a very tricky parameter, since is the advice for the planner how much memory is available for it for internal algorithms like sorting and hashing. How the sorting can appear. For example, you have order by, you can have union, distinct, or perhaps union, distinct, or perhaps you use group by, or maybe you use analytic or window functions, or perhaps you're using bitmap scan. So it can be used to build some internal structure while processing your query. And why is it a tricky one? Because it's available for each and every Postgres backend. And moreover, you may encounter a situation when you have a parallel query, when you have one main process called coordinator and the child process, and each and every child process will have its own workmem. And the second thing you must be aware of that, as I have just mentioned, workmem is just an advice for the planner. It's not a hard limit because there are many regions of memory which Postgres can use to store its data for its internal algorithms. So it's not a hard limit. The third thing I would like to share is about temp buffers. We know that in Postgres we have session temporary tables. Only process creator can access to them, and in case if you don't use it, so feel free to deactivate it by setting the value to 0. And there is one hint that you probably know. But before we get to the hint, I would like also to say about max connections, because if we tune max connections, we must think to tune workmem as well. As we know, it's the maximum number of allowed client connections, and if it's greater than 1000, we should consider using connection pooling, such as PG Bouncer or perhaps Odyssey from Yandex, or perhaps if you're from Java World, you can use application server connection pooling like provided in Wildfly, or perhaps you can use Hickory and Flexipool and many others. So, and what is the hint? We should follow this rule that the value which will be calculated, it shouldn't exceed the maximum amount of memory on the server to avoid Postgres termination by out-of-memory killer. Which main purpose is to protect our operation system from memory leaks. And when it sees then that Postgres children are consuming too much memory, it just terminate the Postgres main process, because it thinks that postmaster is responsible for its children action. If you follow this rule, there are less probabilities that you will face OM killer. Of course, there can be some mistakes like memory leaking or something cannot be right in Postgres internal logic. However, in a normal workload, if you follow this rule, there are less probabilities that you will face OM killer. And I would like to say some words about logging parameters. For the first time, it may sound strange. Why should we talk about it? However, as my colleague Andrey Zubkov has mentioned before, PG profile cannot show us everything. For example, there was interesting situation with so-called infinite recursive query. Suppose we have some data structure, some organization structure like employees and their bosses, and we want to show our users this data structure on our screen. To be able to do that, we need to write a recursive query using common table expression, and the trickiest part here is to provide a good condition, which we can use for our exiting, and in some cases this condition will never be reached, and as a result, this query will start generating a lot of temporary files. As my colleague Andrey Zubkov have mentioned in his presentation, we can use pgprofile to see how many temporary files were generated, but the trickiest thing is that its pgprofile can detect it when the query has finished. And in case of infinite recursive queries, it doesn't finish at all. And therefore, pgprofile cannot, not pgprofile, no pgprostats, no pgpro Postgres workload repository cannot show it to us. And the only thing we can do is to activate log temp files and to see which queries are generating a lot of temporary files. And I have an situation with our customers when this query have almost consumed all available disk space. And as we know, Postgres doesn't like the situation when it doesn't have any disk space. And as a result, what should we do? First of all, we can activate this parameter log temp files. The second thing we should do is to activate logging collector. It's a special process who grab information from our Postgres backends and write them into files. And after that, we can also, and what can we also use? We can use temp file limits. I don't place it here. However, you can protect yourself from this type of query. And if you wonder what was the reason was that our customer has forgotten that null and empty string are not the same. Are not the same things in Oracle. Empty string and null is the same thing, but in Postgres are different things, and it makes sense because null is unknown value and empty string is not unknown value. It's just empty string, and as a result, we have a row in our data set which linked to itself, and therefore we will never finish our query. You may encounter this situation is seldom, but it's pretty nasty and hard to be detected. So beware about it, and feel free to tune your logging to provide you more information, to get more information, because pgprofile cannot show everything to you. And I also would like to say some words about logline prefix, and I want to say about %e and %x placeholder. %e is SQL state error code, allowing us to differ application mistakes from internal mistakes. Suppose we have some so-called user-defined exception. It's a normal situation because we protect ourselves perhaps for bad user input. But in case if we have some internal code, it seems that something is not right with our database, and maybe it's the right time to ask Postgres expert to help. And %x is a transaction identifier, which is very useful to differ so-called transaction with one command and transaction with many commands. As you may know, transaction can have one command, and there can be cases, for example, like deadlocks, when the processes are waiting for each other, and if we don't activate this transaction identifier in our logline prefix, it's not obvious to understand which transaction one or another command belongs to. And as a result, it's not obvious to see the reason of such deadlock. But therefore I also advise you to place this transaction identifier, because we can see the whole scenario. We can then go to the application source code, and then we can find the true origin of our problem. And what I also suggest you to do, it's also a good thing to set your idle in transaction timeout, since this transaction identifier can show us the case when transaction has done its action, but it hasn't committed or rolled back this situation, and it's bad because our internal logs are not released. And therefore, if some process wants to work with the same data structure, it wants to grab these logs, and it can't do that. And as a result, eventually, our system will just hang on. So, and this transaction identifier can help us to detect such kind of cases. So please be aware about it. And I would like to say some words about Postgres Planner. Of course, you have already known about default statistics target, allowing us to improve accuracy of our statistics for building a more accurate query plans. However, I would like to tell you something about join collapse limit. Of course, you have already known about join, like left join, inner join, right outer join, full outer join. And of course, you have specified a correct order to join your tables for producing a final result. However, if you have ever looked into execution plan, Postgres explanation plan or execution plan, it's a way how Postgres will execute your query. You can see that your order may differ from its order. And there is a reason, because Postgres is trying to find out the best way to join our data sets. For example, suppose we have an employees table and we have employee statistics with salaries. And what is the best join order? The best join order is when we grab some data from our employees, we filter it, and then we calculate the statistics for the remaining rows. It's a good way of joining. And the bad way of joining is when we grab all statistics for each and every employee, we calculate it, and then we join it with the remaining data set. And of course, this query will work longer than the first one. So, and if you leave this join collapse limit as by default, and by default the value is 8, there can be some situation when, for example, your join number is 10 or 12 or maybe more, Postgres will not be able to choose the best suitable join order, and as a result, you may have a query with a very poor performance. So feel free to increase it, and you'll be okay. The next thing I would like to tell you is about Mamunso as an active Zabbix agent, which means that it connects to Zabbix agent and passes it the set of metrics in a way that Zabbix can understand. Mamunso was also designed in Postgres Professional company, and it allows us the following feature. It can provide us various metrics about the oldest transaction seed, the longest query execution time, and this monitoring tool is very important. It allows us to find out the interval, the time when there was some problems, and we can use this interval to build a PG profile or PG Pro PVR report to see exactly what's going wrong. And if you install Zabbix agent by default, everything you will get is CPU consumption, disk consumption, and memory consumption. However, there is no statistics related to Postgres database. And by the way, if you are using Zabbix server version 5, there is the second version of its agent, and it contains metrics for database. And by the way, our colleagues have participated in its developing. So let me show you what Mamunso can provide to us. The first thing is about statistics connection. What should we aware of? The first thing we must be aware of is number of idle and transaction connections. It means that perhaps we have some problems with our applications. If we see an increasing number on this chart, then perhaps that something is going wrong, and therefore we must consult our logs and our application logs to see what's going on. And number of waiting connections, when we have some problems with internal mechanisms, and therefore our process must wait for acquiring the suitable logs. Or perhaps we have some some deadlocks, or perhaps we don't release it as soon as we finished our job. There can be many reasons. It's not only the internal Postgres problems. The second thing I would like to show you, we can monitor our database size to make sure that we have all our disk space. So we don't encounter a situation when we have run out of disk space. And as I have just mentioned, Postgres doesn't like this situation at all. The third chart I would like to show you is about Postgres checkpoints. It's a situation when we flush our dirty data pages, modified data pages to disk and synchronized with them. And this chart allows us to see if we tune our checkpointer and background writer correctly. And the next interesting thing is Postgres log sampling, which allows us to see what types of log we have encountered, and it's also a good chart because we can find out what time interval we should analyze by using PG profile or PG Pro PVR module to see what's going on. Why do we have so many logs? And I would like to share with you a list of useful extensions. Of course, you have already known about pgstat statements. However, I would like to mention that from Postgres 13, there is a feature allowing you to see how many time was consumed by planning query. As you may know, there can be some awkward situation when we have a little execution time but a large planning time. So this extension can also help you to see which queries are planning the most, have the most planning time. pgstat key cache is another extension allowing us to see what queries are consuming the most CPU system and user time. And I would like also mention about auto-explain because my colleague said that PG Pro PVR and PG Pro Stats indeed can provide us explanation plan. However, it doesn't provide us any information about bind parameters, and auto-explain can do that. And based on this information and information from PG Pro PVR, there is everything I need to know to tune this query. The fourth extension is PG weight sampling for collecting history of weight events and it types. And Mamunso also retrieve data from it. Of course, you have already known about PG profile, but I think it's a suitable place to mention it here. You can also you can see SQL query statistics, and my most favorite parts are usage section and input-output weighting, output weighting section, and also shared blocks, how many blocks were fetched during query execution, because they can be a good candidate to optimize. Because in many cases, it means that we used an appropriate index, or perhaps we have encountered sequential scan on a big table. So, and I would like also mention about PL profiler. It's useful when you have a lot of PLPG SQL query, PLPG SQL procedures and functions, and you have some problem, you don't understand what's going wrong, and PL profiler can grab such information and visualize it, so you can see what sort of procedure or function has consumed the most time, and it's a good candidate to optimize it. And my colleague has already mentioned it, but PG Pro Stats is a combination of pgstat statements, pgstat key cache, and PG weight sampling, but it's only for Postgres Pro customers, and as far as I know, it's available from Postgres version 12. And of course, PG Pro PVR is an enhanced version of PG Profile. It can talk to PG Pro Stats and retrieve information from it, but it's also only for Postgres Pro customers, and it's available for you from version 12. Okay, and this is a section from PG Profile from our last audit. We can see that this query is consuming the most CPU time. We can also see that this query has read a lot of blocks, and therefore it's a good candidate to analyze, and it reveals that our customer has used an appropriate index, and it was like condition with trailing percent, I mean percent in the end of our pattern. And in such case, you must make sure that your index contains text pattern ops or varchar ops. If you don't do that, Postgres Planner won't use it, and as a result, your query performance will be poor. And now let's return to our huge pages and why should we be aware about it. If Postgres shared buffers greater or equal than 20 gigabytes, it's highly recommended to use it to reduce overhead while working with large and continuous regions of memory. For activating it, you should take the following steps. The first step we need to do is to find out our postmaster identifier by watching the contents of this file, pgdata postmaster.process identifier. Then we should find out VM peak by watching the contents of this file, and postmaster pid is actually identifier of your process, which you have found out on previous step. The third thing we need to do is to find out what huge page sizes is from procmem4, and then we should divide VM peak by huge page sizes and save the calculated value and etc. sysctl.conf as this parameter. However, I must warn you about one thing, because if we consult Linux documentation, we will see that besides sysctl.conf, there are various places like run sysctl.d, like etc. sysctl.d, like user local lib sysctl.d, like user lib sysctl.d, lib sysctl.d, and only then etc. sysctl.conf. So you should in some cases consult your system administrator, because they can have the configuration files to make sure that your settings can be applied. Because the priority of sysctl.conf is the last, as you may have guessed. And the second thing, which is related to huge pages, is so-called transparent huge pages. The original design was to provide huge pages for application without allocating them explicitly. However, the practice shows that the result is that our CPU is doing a lot of things from kernel behalf. We have a high CPU consumption on system time, and in order to reduce it, we must deactivate it. The first thing we need to do is to place these parameters to this file, however, and to reboot our Postgres. However, these settings will not survive after the server's reboot, and therefore we must do extra things. What can we do? In fact, I must say that I provide commands for Ubuntu operating system. However, many tips can be used on Linux-based system. But in this presentation, I decided to do it for Ubuntu. First of all, must install grub2 command package. Then we should add huge pages calculated value at the end of parameter grub cmd line Linux default in etc. default grub file. The second thing we need to do is to deactivate transparent huge pages. We should place this value at the end of this parameter in the same file. Then we should run update update grub to apply the config, and then we should reboot the system. After the server's reboot, we should check that we have applied our settings correctly. And to do that, we should run this command. And if huge pages total greater than 0 and unknown huge pages are equal 0, then our settings have applied correctly. And the next thing I would like to share with you is how to prepare for the unexpected, like memory leaking, like memory access violation, like problems with logging, and so-called an internal stuff. One of our customers have reported that they have a problem with memory consumption. They have noticed that one of Postgres backend was consuming a lot of memory, 1 gigabyte, and they haven't built any index. And they haven't calculated, and they didn't have any heavy workload. This was a very strange thing. Therefore, they asked us to investigate. And in order to find out the problem's origin, we must find out function calling hierarchy, also called stack traces. And let's see how it looks like by default without installing any additional packages. And we can see something unclear because we have some question marks, we have some brackets, we see some names, perhaps it's function, perhaps it's something else. We don't have any parameters, we don't have any precise stack trace. In short, we don't have anything. And therefore, we must install something additional, and it's so-called debug info packages. They provide us additional information such as variables and function names and how they're calling each other. And it's essential because it allows us to see more accurate stack trace that leads to the problem's origin. However, I must warn you that when you update your Postgres, you must make sure that you install an appropriate version of debug symbol packages, since it must match the server version with minor precision. For example, for Postgres version 13.2, the following packages should be installed. The first package is for client applications like pSQL, pgdump, pgrestore. The second one is for Postgres itself and its extension in contrib module, like pgstat statements, like after-explain, like UED OSSP, and many others. In case you are using Perl for your procedures, you should install this package as well. And in case if you're using PL Python for communicate with your external services, you should install it as well too. And in case if you have some external extensions like pgwait sampling or pgstat keycache, you should make sure that you have installed it separately and the debug symbol as well. As pgstat keycache statement extension is concerned, you should install the following packages, and you will have almost all information you need. The second thing is sometimes optional. However, in some cases we need to install some packages for operating system itself, and the reason is that Postgres have some dependencies. For example, it uses libxml2 and libxslt when it works with XML. It also uses so-called the lib library when it compresses our data when we try to do pgdump, and it uncompress it when we are dealing with pgrestore. And what can we do? First of all, we need to write the ways for repositories. We can do it the following way. Then we should place it into a separate file. The second thing we need to do is to import a key and run apt-get update. And after that, we should install apt-get install GNU debugger. GNU debugger is an utility allowing us to attach to Postgres backend and to see what it is doing. What it is doing the right.
Понятно.
Okay, how can we do that? We should run the following. We should run the following command. Then GNU debugger will display a list of debug symbols packages that needs to be installed. In the case of clean installation of Ubuntu 20.04, the command will look something like that. And let me show it to you. It will look something like that, but in your case it can. But in your case it can be something different. So, and let's have a look how it looks like after installing debug info packages, and we can see it's much better. We can see more accurate stack trace. We can see parameters. We can see source code file name. We can see line number when the function was calling. And it gives us the right place to find out the problem's origin. And in this case, it was memory leaking in function get cached plan. And our developers fixed it. And when we sent this patch to our customer, they said that they haven't encountered this problem anymore. And without this technique, we will never be able to find it out. And if you don't mind, I would like to tell you one interesting story about row-level security, which was encountered in Postgres original version, so-called vanilla version. Our customer have also encountered memory leaking, and and the application was unique since it used a lot of row-level security and a lot of temporary tables. They have a huge calculations, and during that they have created and destroyed temporary tables. And as a result, what row-level security from Postgres point of view? It's a tree with a root and leaves. And when we revalidate when we revalidate some row-level security and plan, there was the case then root was deleted, but not the leaves. And therefore we have a memory leaking, and we use the same techniques, and we reproduce the situation. Then we contact the Postgres community and we ask them, do they agree that it was a bug? And one of Postgres major contributor and core developer has contacted us and said that indeed it was the case. And they made it a series of patches, and when we applied these patches and sent them to customers, they were able to finish the calculation without any memory leaking. So in Postgres world, it's essential to be prepared for the unexpected. Memory leaking is one of such cases. And the next unexpected case is segmentation fault. Is a failure condition which is associated with access memory violation when we try to communicate with region of memory which doesn't grant us to access, and therefore the process stops working and generates a core dump file, which is a state of a working memory of a computer program at a specific time of crashing. And the first thing we need to ask ourselves where to find this file. And the answer is use kernel core pattern, and you can see the following options. The first option is upport. It's when you send your statistics and core dump to Ubuntu bug tracker. However, it may be not a good solution since some code can be appropriate, and the developers don't want that you have sent something to Ubuntu bug tracker. So it may be useful to install systemd core dump. And if you do that, you will see that kernel core pattern will looks like something like that. And you can list it by using core dump CTL. However, I must warn you that there is so-called retention policy. So if you have ever encountered a bug, you should place it into core dump into a separate directory and place an output of dmask and Postgres configuration file. So when you ask some Postgres expert to help you, they will come and see this core dump, and then they will see a lot of things like function name, variables, the values, stack traces, everything they need to do to find out the problem's origin. So be aware about it. And this is an example how you can how you can set options for gathering core dump. And the last thing I would like to share with you is about limits. You see, when you're generating your core dump file, it may be the case that its size has exceeded the maximum allowed size. And therefore, this core dump may be incomplete, or there may be such situations that you will not be able to find it. And therefore, we must tune our hard and soft limit. Hard limit, and in the case of core file, you can add the following lines. And I would like to say some words about file size also. It concerns pgdump and pgrestored. One of our customers have encountered a problem that they will not be able to restore from a dump and to create a developer stage. And the reason was that the dump size was exceeded the maximum allowed file size, and therefore they have uncompleted pgdump. And when you have incomplete pgdump, you will not be able to restore it. And when we tune this file size and we try our customers to do pgdump again, they're able to do that without any errors, and they'll be able to restore it. And by the way, I must warn you, pgdump, pgrestore is not a backup strategy. You can use it to quickly create some stages for developers. So And in case if you want to run Postgres as a service by using systemd, I highly recommend you to consult this documentation, since there are various places where you can use to place your settings, for example, in systemd unit files. So it's a good practice to consult manual to see if you have tuning everything correctly and not break something. And as I have promised, you can see the links that covered every topic we have mentioned. And actually, this talk has finished. Thank you very much for your attention. Thank you very much for coming. It was a great pleasure for me to share this information with you, and it was a great honor to represent my company. So if you have any questions, feel free to ask, and I'll try to answer them. Thank you.
Oh, thank you, Peter. So far, we have just one question. If PG Pro Backup is required a separate license, then probably you can tell a bit more about our open source projects.
Well, as far as I know, it's under Postgres license. So you are free to download and use it. And however, there are some caveats I must warn you about. I have warned you about. There are three strategies how you can create incremental backups, and one of them is ptrack extension. And as far as I know, this extension is the part of our Postgres Pro forks, to be more precise, in Postgres Pro Standard and in Postgres Pro Enterprise. I'm not sure if ptrack is separate supplied as a separate extension. You should contact sales for more information. But if you use, for example, data page or Delta, there is nothing wrong in it. And but if you use the third one, you will need to patch your Postgres, and I'm not sure if these patches are provided by free. But in general, PG Pro Backup is under Postgres license, so you can also feel free to maintain and contribute if you feel you're ready and you understand its logic. I hope I can answer the question.
Yeah, thank you so much. I don't see any other questions right now. Probably we can wait a little bit, but I'm not sure if we are going to have more of them. So let's wait. Probably Andrey can add something about PG profile, the future plans, and how to contribute to PG profile if people want to do something to develop this project.
PG profile future plans includes support of Postgres 14 version, which will include new statistics. The main weighting statistics of Postgres 14 is some sort of Oracle deep time analog. Of course, it will be supported in PG profile. So PG profile is located on GitHub. If you want to contribute, you feel free to contribute to it. And read the docs. There are much details that you should know about PG profile.
Okay, thank you. I don't think that we have any other questions. So thank you for your talks. Both Peter and Andrey did great today, I think. And thanks everyone who attended. As I have already said, we will share with you all the materials from this event. Please expect another email from me with links to the video and slides soon We would also recommend you to attend our next event, NoSQL Day with Postgres Pro, Ongres, and DataStax. It will be held on May the 20th. And goodbye for now, everyone.
Goodbye. Have a nice day.
Goodbye.